So I'm first going to start off and let you go ahead and get the table of contents. So if you are missing any of the table of contents, please pause this video now and get them while you can. Otherwise, I'm going to move on to the notes. So your first page of notes starts on page 49, I believe. So 49 here. So if you need to, go ahead and pause. The first page that goes in is the one that says linear versus quadratic versus exponential and has all of these graphs and things. The other one that has the tables where it says patterns will be the second one. So this one goes first. So this is page 49, 9.7 linear, quadratic, and exponential models. If you need more time on this, please pause this video now. Otherwise, I'm going to go ahead and show the next page. Alright, so the second page of today's notes is page 50. Same title, 9.7 linear, quadratic, and exponential models. This is the one that says patterns on it with tables. So if you need more time to write that title down, please pause this video now. Otherwise, I'm going to go ahead and start the notes. Okay, so today what we're going to be talking about is seeing the difference on a graph and a table if something is linear, quadratic, or exponential. So if you recall, linear equations are in the form of y equals mx plus b typically. We talked about other forms that they can look like, but this is the most common, like, standard type that exists. And so lines are just always nice and neat, where they have a slope, they have a y-intercept and such, where they just make a perfect straight line. So that is a linear equation or a linear function. If you need more time on that, pause this. Quadratics, however, we've been talking about them this whole unit. They're in the form of y equals ax squared plus bx plus c. And that's the standard form we've been talking about. And they always have a U-shape that we call a parabola. And each parabola always has a vertex, a maximum or a minimum point. So it's very symmetrical, where both sides have the same behavior. Exponential, it's been a little while. They typically have the form of y equals a times b to the x. Okay, so where a is our initial value, so it's actually like our y-intercept, and b is our ratio that we're multiplying or dividing by each time. And it has kind of an L shape, so it grows very quickly or it decreases very quickly, but it has some kind of flattening out point somewhere along that line. So our goal of today's lesson is to sit here and look at different types of data and see if something has linear behavior, quadratic behavior, or exponential behavior. So we're going to first start by plotting all these points and seeing if any of them make this kind of shape, where they're making a line to be linear, a parabola or a U-shape to be quadratic, or where it's like flattening out and has kind of an L-ish shape to be exponential. So this first data set that we're graphing is this set of points. So we're at 1, 3. We're at the origin 0, 0. We're at negative 3, 3. We're at negative 1, negative 1. And we're at 2, 0. Oops. 2, 0, my bad. So we're at 1, 3, negative 3, 3, 0, 0, 2, 0, and negative 1, negative 1. So this one doesn't really seem to have any of those specific shapes. However, if you look closely, if we just kind of ignored this point, ignored this guy, this looks like it's making that U shape. So if you notice, these directions say which model is most appropriate. It doesn't ever have to be perfect. Which one is the best fit? So for this one, I would say quadratic, because it's starting to make kind of that symmetrical shape, and we have a low point, and this one looks like it might be on the parabola. There's just kind of one we have to count as an outlier. So for me, I'd call this one quadratic. If you want to work ahead of me and see if you can get these next two, go ahead and pause this video. Otherwise, I'm going to move on to them. So, number 2, we're at 0, 2. We're at negative 1, 4. We're at 1, 1. And we're at negative 2, 0. So, looking at this one, it started to make that nice L curve shape, because otherwise it doesn't make a perfect straight line. It's not making a U where it's symmetrical, but it's making that L shape. It started decreasing, but then this last guy threw it off completely. So we can ignore that one and can say, hey, this is looking kind of like that L shape where it was decreasing very quickly, but not like a line where it's constant, but it's going to flatten out at some point. It looked there before this outlier happened. So I would say this has exponential behavior. Alright, so let's look at this last one. So this last one, we've got negative 1, negative 2. We're at 0, negative 1. We're at 1, 0. Are you seeing the pattern so far? Ask yourself, what does that look like? And then the last one is 3, 2. Well, looky there. That one actually doesn't seem like it has an outlier, because this seems like this is having a slope of 1. So I would think there's probably a point here that could exist with that to make it a perfect straight line. So to me, this one's the easiest out of the whole bunch, that this one clearly has to be linear. Alright, so that's how to look at a set of data on the graph-wise and being able to tell what kind of behavior something has. Now we need to talk about table-wise. So we've talked about these before, and I just wanted to reiterate it. For each of these, for a pattern to work, no matter what kind of function it is, whether it's linear, exponential, or quadratic, the one or the x's have to be going by the same constant adding or subtracting change. So here it's all adding by 1, because negative 2 plus 1 will give me negative 1. Negative 1 plus 1 will give me 0. 0 plus 1 will give me 1, and 1 plus 1 will give me 2. And that's the same here. It's the same pattern. It's the exact same numbers, actually, for the x's. And for quadratics, it will also be adding by 1. Now, they adjusted their table values slightly. Instead of doing negative 2 to 2, they did negative 1 to 3. So they just adjusted it ever so slightly. So we have to have this be true over here in the x column to even be able to assume anything about the y pattern. So the y pattern is what helps us see if it's linear, exponential, or quadratic. So if you remember with linear, when we're looking at the patterns, the y pattern should be adding or subtracting for it to be linear. So let's see what's happening here. So negative 1 to 2, that is adding by 3. 2 to 5, also adding by 3. Yeah, add 3 to 2 to get 5. What do you add to 5 to get 8? Also 3. What do you add to 8 to get 11? Also 3. So for something to have linear behavior in a table, you're looking for adding or subtracting by the same value. Okay, so this could have been minus 3, and it still would have been linear. Excuse me. Now, with exponential, for this one, the y pattern has to be multiplying or dividing each time, because it has a constant ratio. So if I'm looking at this, I know some of you guys freak out with decimals, but if you want to think, ignore that these are decimals and imagining that this was a 50. Okay, because we can keep adding zeros when you're talking about being behind a decimal point and it won't change the value. think about what you have to do to 25 to get 50. You have to multiply it by 2. Okay? What do you have to do to 0.5, so to 50 cents to get $1? Multiply it by 2. What do you have to do to 1 to get 2? Like, what do you have to multiply by? 2. What can you multiply 2 by to get 4? Also 2. So for something to have exponential behavior, it's going to be multiplying or dividing by the same thing each time. Now, we haven't talked about quadratics. These other two guys we've talked about this semester or last semester, but we haven't talked about quadratic just yet. So whenever you look at these, for something to be quadratic, I want you to treat it like it's linear, and like that's automatically what you should be checking, is if it's adding or subtracting by the same thing each time. So ask yourself, okay, what do I add to 1 or subtract to 1 to get negative 1? Well, it's a difference of 2. Okay? Now think about from negative 1 back to 1. Again, we're talking about a difference of 2. Okay? Now think about 1 to 7. We're talking about 6 this time. Right? Now what about 7 to 17? That's 10. So, right off the bat, this is not having a linear behavior. And I can't multiply any of these things by the same thing to keep a pattern going. So 1 times negative 1 would give me negative 1. And negative 1 times negative 1 would give me 1. But then I shouldn't get 7 for the next one if I'm multiplying by the same thing. However, to know if something's quadratic, break these down even a little further. What is the change between negative 2 and 2? So what do you add to negative 2 to get positive 2? Hopefully you should have thought, hey, 4. Now what do you do to 2 to get 6? Also 4. What do you do to 6 to get 10? I'm seeing a pattern here. That's also 4. So that's how to tell something is quadratic. Is it's like we're going to take that change, find out those differences between the values of just adding or subtracting to find on the second time we've done it the same pattern. So this is where it's still going to be adding or subtracting, but do it twice. Then that'll tell you if something's quadratic. Now, part of you may go, how am I supposed to remember that? Well, whenever you see a question that's asking, okay, hey, tell me, is this table describing linear, exponential, or quadratic behavior? Then you're going to sit there and say, okay, first, does it add or subtract by the same thing each time? If it does, it's linear. If it doesn't, then try to go this route. Say, okay, what's the change between each of these values I just got? If you get the same thing, then it has to be quadratic. But if you don't get either of these to occur, then by process of elimination, let's see if something's doubling, tripling, cutting in half each time, multiplying or dividing by the same thing, then that probably means it's exponential. So, the sub should now be getting ready to pass out the practice to you. So the practice just goes over some more questions like these guys, where you've just got a graph and tell me, like, looking at the graph, is something quadratic, exponential, or linear? And remember to get rid of some of those outliers. Then you'll be given some tables like these and try to see if you can figure out those patterns to tell if it's linear, quadratic, or exponential. If you have any questions, please feel free to message me on Remind. And just a reminder, my Remind is at Brandel AB. So if you have any questions, send me a message. I won't be super quick about responding back, but I'll try my best. Because while you guys are watching this, I'll actually be driving. I'll probably be I'm about halfway to my destination for my robotics competition. So if you have questions, send those to me. It may be my husband's turn to drive at this point, so I may be able to message you back. But please feel free to do it. If you haven't joined, please do so already, because it'll make it easier for you the next few days that I can just send out the YouTube video to you guys through Remind. So holler at me if you have any questions. If not, I'm not going to see you guys till Monday, but you will see me in the next video tomorrow. So let me know again if you guys have any questions. Have a good rest of your day.